Hi there, my name is Stanley Kroll, Sales Manager for J.W. Dunn Corp. And manufacturers of the Orbitool deburring tool. And I'll be showing you some videos and a demonstration of how the Orbitool works and what are its advantages. So the main kind of principle of this tool is two main components. It's a flexible shaft, flexible stainless shaft, the carbide cutter, and the protective ring above the carbide cutter. The purpose of this ring is to protect the wall surface of a cross hole. Any sort of wall surfaces where you don't want any damage, this ring will be protecting those. And the carbide cutter is only going to remove material selectively at the intersection edge. So we can step over here and watch a couple of videos on how it's working. You can use the tool manually in essentially a rotary grinder type setting, or you can use it on a CNC machine, either a lathe or a CNC mill. So here in a manual setting, we have this is essentially a 90-degree elbow with a cross hole burr at the intersection of those two holes. The cutter comes in, and we'll pause it for a moment. The protective ring is what's going to protect all of the wall surfaces, and the carbide burr will remove material only at this intersection edge. And now this is being used in an electrical rotary grinder, and the operator is just moving the tool very easily up and down. So we can see it here again. Cutter comes into the hole. We start the tool up, and now the operator is making a very light filing motion to only remove the burr, and no damage is done anywhere else. Conversely, we can use the tool in a CNC setting. So here again we see the protective ring on the end of the tool. The ring is riding along on the wall surface, and the carbide burr is never touching that wall. So in this scenario, we're going to see it in a lathe setting. The part is rotating while the tool is feeding in. Essentially, we're turning a thread. We're making a thread spiral on the inside of this hole. Now, as we mentioned earlier, in addition to this protective ring, we've got the flexible shaft. So in this CNC setting, we're actually preloading the tool against the wall and bending that flexible shaft. So now we're developing this potential cutting pressure. And as soon as the tool reaches the edge, the disc moves past the edge, and now the carbide begins to deburr. In this case, it's an elbow. Same type of intersection can be a T. This would be very common in hydraulic manifolds or hydraulic fittings, elbows and Ts. So same principle here. The flexible shaft is allowing the tool to build this cutting pressure, and then all of this movement that you see here is happening automatically just by the give of the shaft. The tool is adjusting to the surface as it finds it. We can fast forward a little bit to a mill setting. Same exact principle. We're making a threading motion on the inside of a hole. So either we interpolate the tool around that hole ID, or the tool is stationary and the part is rotating. So now I'll show you a demonstration of that manual, the manual deburring technique. So here we have the cutter, flexible shaft, the carbide burr on the end, and the protective ring. Ordinarily, we never want to spin the tool outside of the hole, but we'll take a little risk here for this video to show you. So I'll keep the tool stable, just to show you that when we run the disc on the fingernail, it doesn't do any damage. It only begins removing material at the edge of the intersection, but no damage on the wall. So here we have an example of a hydraulic manifold. Essentially, this is your cross hole. This is basically a manifold that was cut in half, and you have a series of cross holes that are drilled into the main bore, and that's where you're developing your burr. So we can try to put it in this way so you can see it, and I'll deburr it from the back. So I enter the hole. Where are we? Here we are. I enter the hole. I don't do any damage to any of the wall surfaces. This protective ring is protecting all of the walls, and it's only when I come into this edge that I cut the burr. And the more time we spend, there, the burr is gone now. The more time that we spend there, the more of the larger radius that we're starting to generate. So in this case, I can see what's happening, but if I'm the operator deburring this part in a real-life setting, because I can't damage the wall in any way, I can really do this in a completely blind setting. I'm doing this entirely by feel. So that's the deburred hole, and no damage done to any other surfaces except where we actually need to remove the burr. Now we can see an example of this in a CNC setting. So here the geometry of this intersection, whether it's a T fitting in the hydraulic fitting setting or it's a manifold, it's really the same geometry, one hole drilling into another. With this flexible shaft, we're going to preload the tool against the wall, and anytime we're inside that hole, we don't do any damage to the wall. Only when the cutter is going to reach the edge, then it begins to cut. And because we've preloaded and flexed that shaft, it's going to automatically pop in there. So here, this is the final condition where the tool is fully against the wall, and when we're inside the hole before we reach the edge, then we've got this bent condition. So like you saw in the video, we want to make a helical interpolation inside the hole. So we've come in, we've offset and preloaded the tool against the wall. In a CNC lathe setting, our part is rotating. In a mill setting, our tool is interpolating into a stationary part. But the basic principle is the same, that we have a flex shaft, the tool is spinning, but the disc is protecting the wall, and then as we interpolate down towards this edge, then the cutter begins to selectively remove material at the intersection edge, at the corner where the burr is located. But as it comes around, it doesn't do any damage to the wall. And you can see the full range of tools here, down from about 1.8 millimeter, so for a 2 millimeter hole. This is a 74 thousandths cutter, and all the way up to a single hemisphere 3/8 cutter. And just behind that you'll see the same 3/8 cutter, but in a double hemisphere configuration. So in this full range we see single hemispheres and double hemisphere sizes. The single hemisphere tool will deburr a T-type intersection, T-fitting, elbow fitting, anywhere where you have only one edge that you need to deburr. And sometimes you have cross-type intersection where you're drilling all the way through a bore, maybe through a tube, and now you're generating two internal edges that need to be deburred, and that's where we use the double hemisphere tool. Then we have a custom length that we can make, roughly 2x, so we can make double the standard length for deep hole applications. And then we have a custom pilot tool, which you can see here, with a pilot shaft extending from the front nose of the tool. This would be used in a setting where you want to use the tool on an external edge. While the tools are primarily designed for internal cross-hole applications, we can make a custom tool for external edges if you're looking for one tool that will do the job on inside and outside edges.